Today's lesson, section 6.5a, the law of sines. Obviously here we're going to talk about the law of sines. Now the law of sines is used when we are solving right triangles that have, that we're solving triangles that don't have any right angles. So these triangles are going to be weird and oddly shaped, have different degree angle or measurements, have obtuse angles. So in any triangle, the lengths of the sides are proportional to the sines of the corresponding opposite angles, which is what the law of sines states. So if I have a triangle ABC, the following is the law of sines. So I can write any proportion to describe two different angles at once and sides at once, so that I could solve for something that's missing. So sine of A over A equals sine of B over B, which equals sine of C over C. So when I have a triangle that is missing a side with no right angles, we will set up a proportion to solve. Okay? Now, just like I said earlier, note we use the law of sines to solve triangles that have no right angles, but this is the only instance we'd use this. We don't really use this for just right triangles because they don't need it. Okay, so example 1 says solve the following triangle. I have angle A is 40 degrees, angle C is 45, and side B is 15. Now some of these you can find without the law of sines. So like angle B, you could find by taking 180 minus 40, gives you 140, and then subtract 45 from that, gives you 95. Okay, so then that would be angle B. Okay, so then you have your first angle. We didn't need the law of sines because it was just something that we know how to do. Now if I want to find, let's say, side C, so then here I want to set up a proportion. So in this case, we want to involve the sine or the angle that is opposite of the side that we don't know. So sine of 45, so angle C. Okay. Then we want to set it equal to one that I completely know. So since I know angle B and the side of B, then I want to use sine of 95 degrees over 15. Okay? Then from there, I want to cross multiply, and I want to solve. So then 15 times sine of 45 equals C of sine of 45, sine of 95. And then I want to divide both sides by sine of 95. These cancel out. I'm left with C. So if I plug all of that into my calculator, I get 10.65. Okay? And that would be the side of C. We do the same thing for side A. So let's use a different color here. So sine of 40 in this case over A equals sine of 95. Now you can go and use side of C and the angle of C as well, but because those aren't super exact, you may get an answer that's not exactly correct. So it might be good to use the one side and angle that you have that's like exact, that you started with, to find your values. So cross multiply, I get 15 sine of 40, and that equals A sine of 95. Okay, divide by sine of 95. And then those cross out. I'm left with A, and I get in my calculator 9.68. So now I found angle B, which is 95 degrees, side C, which is 10.65, and side A, which is 9.68. Okay, let's try another one. I'm going to solve the following triangle. Here I have two angles again. So then now I want to take 180 minus 110, which gives me 70, and then minus 20, which gives me 50. Okay, so angle A is going to be 50 degrees. Okay, and now I'll do the same thing. Since I know side C and angle C, that'll be the ones that I'll use for all of my my law of sines proportions. Okay, so now let's say I want to find side A first. So sine of 50 degrees, that's angle A, over letter A. I'm going to cross multiply. A sine of 20 degrees equals 10 sine of 50 degrees. Divide both sides by sine of 20. Okay, so then A will equal 22 point, in this case will be 40, if we're rounding to hundreds. Okay, then let's try solving for side B. So same ratio, sine of 20 degrees over 10 equals sine of 110 over B. And cross multiply. B sine of 20 degrees equals 10 sine of 110. Divide both sides by sine of 20 degrees. And then B equals 27.47. Okay, so then those would be the missing parts. Okay, those would be for the cases when, like the triangle that we did first, you knew an angle, a side, and an angle. Okay, that was that case. And for example 2, this was when we had a side, angle, and then another angle. Alright, so those are the two cases that we would use law of sines with no restrictions or anything crazy happens. Okay, have fun.